Hello everyone. In this lesson we're going to take a look at normalization as it's very important before we can go any further with creation of tables and learning about SQL, about indexes, roles, anything else. So normalization, so help me God. The idea behind normalization is to basically do quality control of the data within a database. Because a database is primarily made up of a bunch of tables, normalization applies to tables. If your tables have the proper quality, we refer to these as various normal forms, then we can be sure that we minimize duplicate, redundant data, we make it easier, faster to find and maintain data, and we won't create garbage. That's the whole idea behind normalization. Now, if you ask someone or if you search the web for a definition of normalization, you get something that looks like this. Every non-prime attribute of R is non-transitively dependent, in other words, directly dependent on every candidate key of R. Which, while correct, probably doesn't make sense to most people unless they've been through some heavy theoretical database concepts or relational algebra concepts. So let's see if we can make normalization a little bit more human understandable. So we have several normal forms. There's a first normal form, second normal form, third normal form, Boyce-Codd, fourth normal form, fifth normal form. And the higher you go in the normal forms, the better quality of the data. But like with anything else, as you increase the quality, the costs grow. In this case, the costs refer to the cost of computational power, memory usage. That stuff grows, the storage that is required, and things get slower and slower as you go up in normal forms. Most databases today are somewhere between second and third normal form. So let's see what these are, and they are cumulative. In other words, you cannot be in, say, third normal form but not in first. You got to be in first, second before you can be in third normal form. So first normal form applied to a table states that a table has a unique key, that each field should contain one value. In other words, we cannot have any kind of a comma-separated value or arrays or things like that. And no repeating groups. Let's take a look at a normal form violation, the first normal form violation here. Here we do have a primary key, so we do have the unique key, which is great. But as you can see, we have this field, contact field, which has Martin Brown, Karen Dick, and Jack Watkins, which is a repeated group, basically, or repeated values, depending on who you talk to. This is another first normal form violation, adding multiple contact columns to accommodate the various people. So this is another violation. How do we address first normal form violation? Well, the solution is to create another table. In this case, we call it customer contact, which has its own primary key, ID, and the customer ID is a foreign key, which is coming from this table. So I can say that, Acme Corp, which is customer ID 1 over here, has Marsha McDonald as the customer contact. And this is how we get around the issues that you saw with first normal form. Second normal form's definition is any non-key field, so anything that's not a primary key, should be dependent on the entire primary key. We cannot have partial dependencies. Let's see what this really means. Let's take a look at this situation where we have a compound primary key in this events table. I have an ID and a date, and you can see that while ID is not unique, the date and ID combination are unique. So the combination of the two is forming the primary key. This table is in first normal form. We do have a primary key and everything is basically, has one value. You cannot break down the course title or the seats or the room or date or ID into any further. Into any more, atomic values. So we do have first normal form. Why is this not in second normal form? Well, let's take a look at the situation where we have a non-key field, namely course title. If you take a look at course title, if somebody was to reach into this table and change that SQL 101 to ASP 101, this is still in first normal form. This is still unique keys here. But now we have an inconsistency. If I look at the course title, Intro to SQL, I don't know if this matches SQL 101 or if it matches ASP 101. That's because I have partial dependency here. That is, the course title is really the way it's written means that it matches SQL 101. But if somebody was to make this change, this table is still in first normal form. And this is why it's not in second normal form, because we can make some changes like this. Changes like this are possible and they would create inconsistencies. So how do we solve that? We create another table. In this case, we'll create a courses table, ASP 101, SQL 101, DB 101, and the events table has these two listed as we had before. SQL 1, ASP 101, SQL 101. The combination is still there as the primary key, but notice that the course title has been removed. It's basically removed over here to allow this to be in second normal form. Both of these tables are in second normal form. Now, a word here to remember: if a table is in first normal form and the key is not a composite or a compound key, then it is in second normal form. The only time you really have problem with second normal form being an issue is usually when you're dealing with a compound key, so keep that in mind. Third normal form goes a step further. It says that no non-key fields, that is keys that are not primary keys, should have any dependency on another non-key field. So remember, with second normal form it was there must be complete dependency on the primary key. You cannot have partial dependency. Here we're saying if we have a non-key field, there cannot be dependency on another non-key field. The dependency should only be on the primary key. Here's a table that's in first and second normal forms. We can see it's in first normal form. It's got the primary key. Each field is divided up into its atomic form. We cannot break down any of these columns any further. There is no partial dependency on the primary key, so we're in second normal form. But we have a problem between room and capacity. And here's the where the problem comes in, because we do have a room. The room can tell us what the capacity is. Looking at this, I have room 11 repeated here, for instance, and capacity is listed at 24, which I assume is correct. But if somebody was to reach in and change one of those capacities to say 22, then I really don't know if room 11 has 24 people capacity or 22 people capacity. We have a dependency between two non-key fields, and that's why it fails third normal form. That's the reason. Here's another example of third normal form violation. I have a table which is in first and second normal form. I've got a product ID, I've got this unit price and quantity. Creating a total is unnecessary because this is dependent on these two. If somebody was to come in and reach in and change, say, this 1200 to 1000, then I have clear inconsistency because I have unit price of 400, quantity of 3. Should be 1200, but it's been changed to 1000 here. So that's why we do not put columns that have dependencies in order to achieve third normal form. There is a common third normal form violation that you see, and we actually created our table for a student where we put in a city, state, and say zip code, where in fact the zip code itself is sufficient to tell us the city and the state. But this is such a common way for people to deal with addresses that it's generally always implemented like this. So don't let it bother you. Like I said, most tables are somewhere between second and third normal form, And that means that most databases are between second and third normal form. So, normalization, first normal form is the key, second normal form, the whole key, dependency on the whole key, and third normal form says, and nothing but the key. So help me God. I hope you enjoyed this lesson. I hope you found it useful. And please don't forget to share your knowledge with others. And if you enjoy these videos, please share them with your loved ones and your friends.